going to look at the composition of functions. What this means is, I think we're familiar with doing like f of 2. I subbed 2 in for x in my f of x function. The difference is I've got now f of g of x, like I've subbed the entire g of x function into the f of x function. Another way to write it is f of g of x, that little circle right there. F of g of x means the same thing. You are subbing in the g of x function into the f of x function. Now, what happens with the domain? The domain of f of g of x is the set of all x in the domain of g, such that g of x is in the domain of f. So, like, what does that even mean? Well, domain has to do with x's, and those are what you substitute into your function. You substitute whatever x values in. Because you are subbing the entire g of x function in, you need to know what the domain of your g of x function is, and then you can look at the overall f of g of x function. So let's see how this works. They gave us two separate functions. We've got the f of x and the g of x function. Part A wants us to evaluate f of g of x, which another way to say the same thing is f of, in parentheses, the g of x. This means I have to substitute the g of x function into the f function. So this will give me f of my entire g function, which is 4 minus x squared. So like every time I see an x in the f function, I will substitute the entire 4 minus x squared. Now, the f function was x plus 2, so I'm going to have the entire 4 minus x squared in for this x right here, and then plus 2. So there is my f of g of x. As far as substituting things in, I've talked about this before. I substitute things in with parentheses in case there is any multiplication or any other operations really that I need to take care of with the entire parentheses. In this case, I didn't really need parentheses, so I can just do 4 minus x squared plus 2, which if I totally simplify, the 4 plus the 2 is a 6. So my f of g of x equals a negative x squared plus 6. So then in part B, they want us to do f of g of 1, like they want our x to be a 1. I'm going to do f of g of 1, which just to clarify, these two things are saying the same thing. They both say f of g of 1. I'm replacing x with a 1. So negative 1 squared plus 6. So this will be a negative 1 plus 6, which is 5. All right, so my f of g of 1 equals 5. They can also do this backwards. They can do g of f of x. Again, if I write this in another way, it's saying g of, and then I am subbing f of x into the g of x function. So in this case, I'm going to do 4 minus, and then instead of x squared, I'm putting the entire f of x in there. So entire x plus 2 is squared. To simplify, I'm going to have to distribute x plus 2 times x plus 2. Now keep in mind I'm subtracting the whole thing. So I will end up with x squared. I got a 2x and another 2x, so 4x. And then 2 times 2 is 4. Okay, so I have to subtract that whole thing. This means I get to 4 minus x squared minus 4x minus 4. My 4 minus 4, those are going to add up to 0. Those are gone, which means my entire g of f of x is a negative x squared minus 4x. You can also say g of f like this, g of f of x. It's the same thing, negative x squared minus 4x. Keep in mind, this is now different than the original one, f of g of x and g of f of x. They're not the same thing. Sometimes, but not always. Now, part D, where I am subbing a 0 in for the x. So I'm going to get negative 0 squared minus 4 times 0, which is 0. So my g of f of 0 is 0. Or in other words, my g of f of 0, like that, still 0. Either way. Okay, so two different ways you can say the same thing. All right, so let's look at the domain, which they told us a bit about the domain. The domain of f of g of x is the set of all x in the domain of g, such that g of x is in the domain of f. So again, just to clarify, that means my domain has to do with like what I'm plugging into my function. And because I'm doing f of g of x, that means I'm plugging the g of x function into the f of x function. And whatever I'm plugging in, which in this case is g of x, that means that I have to care about the domain of that. So I'm going to look at f of g of x, and I'm plugging g of x into the f of x. Because I'm plugging that in, I need to care about the domain of this, which because of the square roots, I can't take the square root of a negative number. Let's figure out what makes this 0. 0 is cut off between positives and negatives. So let's subtract 9 on both sides. So I'm going to multiply by -1 on both sides. I got positives. And then I will take the square root of both sides. Reminder, the square root will give me a plus and minus, positive and negative 3. And then f of, I'm plugging the g of x into my f function. So instead of x squared, I'm doing the entire square root of 9 minus x squared. So there's my x squared minus 9. My square root squared, those are inverses, so they totally undo each other. I have a 9 minus x squared and then minus 9. So 9 minus 9 is 0, so I'm down to just a negative x squared. So what happens a lot of times is people think, oh, all real numbers is the domain of negative x squared, which is true, but you have to keep in mind the fact that domain has to do with what you are plugging into your function. We plugged in the entire g of x function, and the domain for that has to do with these guys. Let's look at our number line. I'm going to use -3 and +3 on the number line, and I'm going to test each of these sections. So if I test like something over here, maybe like a -4, I'm testing this in the g of x. The g of x would have been the square root of 9 minus, and I'm trying a -4. So this would be the square root of 9 minus 16, which that gives me the square root of a negative number. So for that reason, this section is out of my domain. Let's test a number in the middle there. Maybe I'll test like 0. The square root of 9 minus 0 squared. So that'll be the square root of 9. It's a positive 9, so I can take the square root of it. It even comes out to a nice pretty number, but I don't really care what the number is. I just care, can I take the square root of 9? And yes, I can. So this middle section works. And then I'm going to test this last section right here. I'll pick like 4 or something. Anything in that section. Really, I could pick like 25, whatever is greater than 3. And I'm going to put it in for the x. Again, I'm testing the g of x function. Then I will get the square root of 9 minus 16. Again, I've got basically the square root of a negative number, so that is not in my domain. That section is out, which means that I don't have any restrictions on my final function, but I did have a restriction on the input. Usually I input x's, but I was inputting an entire function, and there are some restrictions on that input. So that would be from -3 to 3. And as far as including them, if I include the -3, again, put this in your function here, 9 minus -3 squared is 0. Square root of 0 is 0. Okay, that works. I can put that in. Same thing for +3. If I put this +3 in here, then the 9 minus 3 squared is like 9 minus 9, also 0. I can take the square root of 0, so that's included as well. I did that as an interval, and depending on what question you're doing, some of them want intervals and some of them want inequalities. So I could say the same thing with an inequality. Reminder, domain has to do with x's, so I could say that these are the x's between -3 and 3. Notice they had the less than or equal to, like I am including the -3 and the 3. So these are two different ways to say the same thing about the domain. All right, and then number 7 here, given f of x equals 2x plus 3 and g of x equals 1/2 times x minus 3, we're going to find the f of g of x and the g of f of x. F of g means I sub the g into the f. I'm going to have the 2, and I sub the g in there, plus 3. It's like 2x plus 3. But I have to put this entire g function in there. So this will be a 1/2 times x minus 3. To simplify this down, I get 2 times a half is 1. Great. X minus 3 plus 3, which I don't really need the parentheses on this. So it ends up with -3 plus 3 is 0. All I end up with is an x. So my f of g of x is x. Next up, they want the g of f of x, which that means that the f function is being subbed into the g function. So instead of 1/2 times x minus 3, I have to do the entire f of x function minus 3. All right, so my f of x function is 2x plus 3, and I will put this in parentheses. Okay. I don't have anything multiplied by the stuff in parentheses there, so I'm going to drop those and just have 1/2 times 2x plus 3 minus 3. Okay, +3, -3, those add up to 0. Go on. And then that means I have a 1/2 times 2x. Well, a half of 2 is 1, so this also equals x. my g of f of x also equals just a plain x. Now, keep in mind f of g of x and g of f of x are both x. This is kind of a special case. It means that these are inverse functions. So if they are asking you if they're inverses or not, this is a way to test and see. All right, have a good day, guys.